Hello dear students, so this is our another lecture on the differential equations, because in the previous topic we have discussed one problem related to those differential equation, and now today's that problem is again on the differential equations, and the problem is that the motion falling in a resisting force may be described by this relation. So the relation for this force is given by that's m dv by dt equal to that's mg minus dv. M is basically the mass of that body, and g is that acceleration due to gravity, and similarly v is the velocity, because these parameters are known to us. And in addition to that, where the resisting force, this force of a falling body, because a body is falling under the resisting force, that resisting force is proportional to the velocity, because this is given from this relation that m dv by dt equal to mg minus b into v, right? Now, what basically we need to find? So we have to find the velocity and the calculate the constant. तो हमें velocity calculate करनी है, and we need to find the constant, because when you integrate that equation, or you need to find that constant by dividing that v of 0 equal to 0, right? So this is basically simply a differential equation, and we need to solve it. So we can use some conditions like the condition is given that v of 0 equal to 0, right? So first of all, let us have a look on the differential equation. So this is a first order linear differential equation, and we can write this as, that's m dv by dt. So m dv by dt equal to that's mg minus dv. Okay, so you can rewrite this as, so dv by dt will be equal to, or you can rewrite this as okay. So this is inhomogeneous differential equation, because you can have the something on the right hand side. So this is inhomogeneous differential equation, and we can calculate this or can compare this equation. So this is the inhomogeneous differential equation. This is inhomogeneous. If you compare this differential equation with this, that's dy by dx. Right? So why I'm writing? Because our g, so it varies because the acceleration due to gravity. So that's why you can write that it's a function of x. So it's a function of that time, right? Because it changes when you go from some point to some another point, right? So if you compare this inhomogeneous differential equation with the general differential equation, so p of x will be equal to b by n, and q of x will be equal to g, right? So you can rewrite then. So what will be the solution? So first let us write now. So we can write that p of x will be equal to, so that's b by m, and q of x will be equal to g. Okay. So what will be the solution for this differential equation? So you know that, so the solution can be written as, so we can write that, because if we have a differential equation of this type, तो इसको solve करने के लिए, because we can write that for this differential equation dy by dx plus px of y plus q of x, so it is solution will be y of x will be equal to e raised power minus integral p of dx and integral e raised power integral of e p dx into qx plus c, right? So we can write the solution for this differential equation. That means y of x will be equal to, so y of x will be equal to, so that will be equal to e power minus integral e of x dx p of x dx into q of x dx. Okay, so this is basically the solution for this such kind of differential equation, right? Because everything is known to us, because we know that what's our p of x. So p of x is that's equal to b by m, and similarly q of x equal to g, right? So we know these values and we can substitute. So instead of that, because our differential equation is in terms of that v, right? So v is, so that means instead of that y, you can write that v will be equal to, so this will be equal to e power minus integral, so that's equal to b by m dt to g. Okay. So let us first evaluate this. So you can write this as, so this will be equal to, so v will be equal to, because this v by m is constant because m stands for the mass of the body, mass of a body, it remains constant, and similarly v is our constant, right? So because these are constant, you can take them outside this integral, so you can have only the integration of that dt, so that's equal to t, right? Now inside will be, so inside will be integral of that e power v by m into t into g. Okay. Or you can write now, so okay, so you can rewrite this as, because so in addition to that, because we need to okay, so what should I do next? Okay, now you can write now. Okay, so because this is clear, because e raised power minus b by t, now we integrate this equation, right? So this is integral. So this will be equal to, you can rewrite this as e power minus b by m into t, and you can take that g out. So g will be outside, then integral of that e power b by m. Sorry, it should be plus. So this integration will, because it's e raised power x, so it will be e raised power dm by t, and now the differentiation of this, it will be b by m, it will be m by t, because this will be the denominator. We integrate this equation, so it is e raised power that x square divided by 2x. So instead of that, so we have this b by m, so it will be the denominator, right? So इसको मैं लिख सकता हूँ, you can write this as, when you integrate this equation, that's e power b by m into t dt, right? So this will be equal to e raised power b by m into t into m, right? Because when you integrate this, because e raised power b m, it will be then b by m, or you can write m by t, right? So instead of this, you can rewrite this as, so this, so v equal to, so it's okay, plus that. Okay, that's right. Now you can do one thing, because okay, so you can do one thing, you can put this initial condition. So what's our initial condition? That v of 0 equal to 0 at t equal to 0. So at t equal to 0, our v of 0 will be equal to 0, right? So from initial condition, v of 0 equal to 0 at t equal to 0, right? So that means at t equal to 0, our velocity will be 0. So you can add that this is equal to, it is e raised power that 0, because we have that minus b by m into t equal to 0, and inside will be, that is gm by b e power 0 plus that. Okay, or you can write that, or c will be equal to, so that is minus b by gm, right? Because c is that minus g by bm, right? Because so this is clear from here. Now you substitute this constant in this equation, right? So that means ये जो equation हमारी है, So this equation becomes, that's v will be equal to, that's e power minus b by m into t into that gm by v e power into t minus right. So this is our final velocity, or you can write, you can take that, so or you can keep it as it is, because, or you can take this out, तो इसको मैं लिख सकता हूँ, I can rewrite this as, because v will be equal to, that's equal to e raised power, so what was our equation, so that is minus b by m into t and e power b by m into t, and so what's inside, inside will be, so inside क्या आएगा, so that is gm by v, that is gm divided by v minus v by gm e power minus v by m into t, right? Or you can write this as, so v will be equal to, that is gm by v minus v upon gm e power minus. So this is final velocity that we get for a body which is falling under some resisting force, and the condition was given that the velocity is proportional to the resisting force, right? And initial condition was also given that the velocity will be 0 at t equal to 0. So from that initial condition we are getting that constant of integration, and finally what we get, so the form of that equation that was given, so that was basically, so you just check, so this one. So this equation was basically an homogeneous differential equation, and we have already calculated the solution for such kind of differential equation, and use it, the final solution, you can calculate that velocity and then put those initial conditions, you can get the desired equation, but after evaluating that value of constant, value of this constant of integration, right? So this was all about this, the another problem on the differential equation. Hopefully in our next topic we are going to discuss some more problems related to the differential equation and some new problems on the series solution method, right? Hopefully this will be helpful for you. Thank you very much.